Hello, friends. Welcome to Electronics Club. Today we have with us Dr. Jonas Sundquist, who is the co-founder and CEO of Alex Lab. Dr. Jonas has over a decade of experience and holds 10 patents to his name. He has authored or co-authored more than 20 publications in the field of ALD and CVD process development. Dr. Jonas has received his PhD in inorganic chemistry from Uppsala University in 2003. He co-founded Alex Lab in 2019 in Sweden, which is currently developing a new method of manufacturing semiconductor components cheaper and faster. And the technology has the potential to change the entire semiconductor domain. Today, we will discuss with Dr. Jonas about his company Alex Labs, the new method he is working on, the products, and the future plan he has scripted for his company and himself. So, welcome to today's conversation, Dr. Jonas.
Thank you very much, Annika.
Dr. Jonas, let us start first with understanding about Alex Lab, the inception story, and what inspired you to come up with such a very challenging product.
Yes, so it's discovery we made some years ago in at Lund University in the Nano Lab. So we discovered surprisingly that we were able to fragment nanostructures and cut them in half and dice them up in smaller dimensions by just applying a plasma etch process. So without doing any additional expensive advanced optical lithography or other types of lithography, we were managed to do what the industry is trying to do, and that's to shrink chip dimensions to smaller and smaller devices. And we saw this potential, and we filed patents, and since then patents have been approved, and we have formed a company called Alex Lab in 2019.
Mm-hmm. So could you just tell us more about the management team, the strength of the team, about your partners and the co-founders?
Yes, so me myself, I have a long experience from German semiconductor industry. So I worked since early 2000 in this. You see the fab background here behind me. So it's Infineon semiconductor fab in Germany. Was done for logic devices and memory devices. So that's my background, and I brought up many processes in those fabs, and then I moved more into R&D for the Fraunhofer organization, and also been working as a consultant for the Critical Material Council in California for more than 5 years for chemicals and precursors used in the semiconductor industry. So I have a strong semiconductor background. Then we have CTO Dmitry Suatin. He's experienced researcher and staff engineer from the Nano Laboratory in Lund with long experience on lithography and advanced reactive ion etching. And we teamed up with Stefan Svedberg, who has a background from Swedish telecom industry, Ericsson. He's like Mr. Bluetooth. So a lot of Swedish inventions in Bluetooth technology, mobile telecom. And he has supported us and helped us to start up the company and get going and raise funding. And with that, we also have an experienced board. So we have people from the semiconductor equipment industry in the US, from with background from companies like Applied Materials, ASM, Vico. And with this board, we are able to engage with the global semiconductor industry, both on the equipment side and also on the end user side, so the fabs. So we're talking to the leading edge fabs for logic and memory fabrication globally, so in US, in Asia, in Korea.
That's nice. That's nice. So, when you say that the company is more of an innovative organization and comes with a lot of research and developing the products, could you tell us how is this company actually placed among the competition and what is the USP of the organization?
Yeah. So the competition is not so much more single players. It's a whole ecosystem built up around how to solve lithography for the coming leading edge nodes for the next memory components and logic components that's going to go on into the future iPhones and Samsung Galaxies and tablets and computers. And this is a huge ecosystem. It's no single player, but you can for sure crystallize out very big companies, like in lithography space, the leading company is ASML from the Netherlands, having basically control of this whole market when it comes to lithographic exposure. Then you have other big companies on the equipment side for deposition and etch, like Applied Materials, Tokyo Electron from Japan, and Lam Research, also US company. And in this ecosystem, we enter with a new technology, and we want to offer the technology under a licensing agreement into this market. And our aim is to engage with all players that are in the advanced lithography space for 3 nanometer, 2 nanometer, and future devices. And we want to make the new ecosystem around our technology, which we call atomic layer edge pitch splitting. So that's the method we use to pitch split any feature that you can realize today for transistors or memory devices. And we want to cut those dimensions in half and go to the next step. But in a less complex way. So complexity always generates a bigger cost in manufacturing and investments, and we reduce the complexity, so we need less process steps. Then automatically we will have less emissions, like use less energy and require less equipment investment in future fabrication plants. So this is how we enter the ecosystem, by creating a new technology, and we have the core IP and broadening our IP portfolio as our R&D activities in Sweden continue.
Okay. So when you talk about so much of researchers, when you talk about a product that is going to transform or build an entire ecosystem around itself, there must be several challenges to it. Could you just highlight some of the challenges on two aspects? One, when you were building the organization, and two, now when you are trying to build an ecosystem around the product?
Yes. So it's a cost challenge. So there's to go out of the laboratory. So on a laboratory budget, you can develop technology. You need something like in the range of up to $1 million per year to run the operation. But if we need to go into bigger wafer size, so 300 millimeter wafers, like in factories like the one behind us, and that infrastructure cost, it's more than one order of magnitude higher cost associated with bringing in the technology in such a advanced infrastructure. And this is the main challenge, is to handle that we have a technological risk. We need to prove that the technology work for what we are aiming at, and this, to take all these steps, costs considerable amount of money, and that's why we have to reduce the risk by meeting milestones, and it's a stepwise approach for that, where we extend our runway year by year by getting investment into the company. So yeah, the balance and the trick here is to still have control of the company while this is happening. So you can't sell out cheap in the beginning. So you have to build value, and building value as a startup in this high technology field we do by filing patents around our technology, densifying the core of the IP further with new invention applications, and by meeting always the technological milestones. So as soon as we file a patent or get a patent approved and meet milestone, the value of the company goes up. And but to go into a fab environment, we need considerable investments in in the company, and infrastructure and R&D contracts with facilities that can do this.
Mhm. So, what are some of your strategies to tackle these challenges? You talked about the investment part, but what about the other aspects?
Yes, we have a lab-based process, and the next step is to get this to work on a wafer level. So something like 4-inch wafers, so 100 mm sized wafers. And once that's proven, we will jump over to 300 mm wafer. So these are these technological milestones that we need to achieve in order to attract interest from the industry and to make a proof of concepts, because eventually all kind of proof of concept has to take place on 300 mm wafers. And here the challenge is in Sweden, where we are based in south of Sweden, Lund. There is no 300 mm fab infrastructure, so we have to go to places where this exists. So I'm based in Dresden, Germany. Dresden, Germany has the best 300 mm infrastructure in Europe. There's 3 operational 300 mm fabs here today, plus R&D infrastructure by Fraunhofer. So it's the place to be for 300 mm in Europe, and we are here and we are engaging with this equipment ecosystem that exists in Dresden. So we are running with smaller equipment companies now the first proof of concepts in Dresden as we speak.
Mhm. Okay, so now let us talk about the new technology that you are working on and how is it going to transform the entire semiconductor industry and the electronic industry at large?
Yes, so we address problems on the horizon on several levels. So one is the cost, as I described. So for each new design that is scaled in the next technology node, the cost of fabrication and design goes up, and it's almost like it's close to a doubling rate per in cost. And at the same time, the energy cost for fabrication is going up for each technology node. And we address both these things. Well, the cost we address by having less complex process. We need fewer different process steps. We need fewer etch steps, deposition steps, and lithography exposures to reach the same goal dimension-wise. And this brings down the cost aspect, and the energy is the same. If you have fewer process steps, less advanced equipment, the energy cost per produced wafers will also go down. And this also then relates to all kinds of emissions. So you have from energy, depending on the energy mix where the fab is placed. If it's placed in Germany, you have a mixed pool of 10% nuclear, what is it, 40% wind power, and then another mixed coal, gas, energy mix, which all cause emissions in the form of CO2. And in the processing itself, you have aggressive chemicals that have a high global warming potential, much higher than carbon dioxide, which are also then going out into the environment. So the more etch processes with aggressive molecules we can reduce, the better overall emission situation you have for the technology. So we really address all those things. And finally, what we address is a scaling approach. So we don't know yet how to go beyond 2 nanometer, go down to 1 nanometer dimensions devices. And we see that we have no intrinsic limit in how far we can go, so scaling wise. So we think that we can thereby extend the visibility of the roadmap with our method considerable.
Mhm. So, which are the industries that you are targeting first with this technology?
Yeah, so we have done a complete screening of all opportunities, and we are targeting logic devices. So this is the main processor in your phone or the computer, or any Internet of Things devices, eventually also in other things like consumer products. And the other one is the memory segment, and here we are targeting the short-term memory, the dynamic random access memory, which you find in all your phones, computers, internet servers, which is part of the computing memory. And this if you look for 300 millimeter silicon wafer production, this covers 60 to 70% of all the wafers. So we address a big part of the market.
Okay. So now let us go and talk more about the products that Alex Labs offer. So if you could just highlight some of the very, you can say, flagship offering of Alex Lab. Explain the products a little bit in terms of use cases, in terms of the benefits it brings to the clients.
Yes, so we have an innovative process which can be introduced to market in two ways. One is that we can install and transfer our process into already existing installed equipment in fabs globally. So there is already equipment installed in these fabs in Taiwan, in South Korea, in US at these advanced leading edge fabs, and we can transfer our know-how, and together with the licensing agreement, this could go directly into existing production and replace certain patterning steps that are already in production. And the other one is to, in parallel, we develop in Sweden the equipment itself. So we are optimizing, taking standard equipment and optimizing it for our pitch splitting method to make the process faster, more precise, and less complex.
Okay, that's nice. So when I say, like you mentioned, this country, Sweden, is not quite ready for the semiconductor revolution when it comes to manufacturing. Do you face certain challenges, and how is the government helping you in removing those challenges?
Yeah, so in a European perspective, Europe by itself has lost ground in the advanced semiconductor manufacturing, but it's catching up. So there are promising announcements of new fabs being built. We have the Intel Ireland fab is gearing up for advanced UV lithography right now. So it's being modernized for the latest nodes. We have activities, of course, in Germany, Global Foundries. We have IMEC in Belgium advancing the technology. So, and companies out of the Netherlands that are leading in this field. So we are not dreaming about any production facilities for wafers in Sweden, but Sweden has a strong technology development. So Sweden has advanced automotive industry, aerospace industry. Sweden develops its own fighter jet. It's one of the most advanced machines you can build today. So from a technology side, Sweden has a long track record. So it's an excellent ground to be. We have a highly educated population, more so than many other European countries. So, and R&D infrastructure. So it's a perfect ground to be if you are an R&D heavy organization. And we are exporting technology on a global market. So let's face it, doesn't really matter too much where you are these days, because the sun is always shining somewhere on the world. And after this and during this pandemic, we all learned to communicate like this. So we actually don't need to travel. We managed to do one business trip right before the pandemic. We went to Seattle to a big conference, and then the pandemic came, but we continued working using web meetings like this. So it works excellent. You actually don't need to travel too much today. You can be anywhere in the world, but you need to have a fundament of basic research and development, advanced laboratory and knowledge in semiconductor manufacturing. That we find in Lund in Sweden because of the university. So Lund University is the biggest university in Scandinavia, and it has the longest track record for advanced nano scale nanoelectronics development at the Lund Nanolab.
Mm-hmm. And that's nice. That's nice. So you won't be finding much of a challenge when hiring talent.
No, I mean, we can say in the company, actually only one person is from Sweden, born in Sweden. That's Stefan Svedberg, chairman of the board. I'm from Finland. we have two gentlemen from Iran, and Dmitry Suetin, our CTO, is born in the south of Russia. So it's we come from all parts of the world, and it will continue to be like that, like everywhere in the semiconductor industry. It's the same sort of what's happening in since long in Silicon Valley. It's people come to the centers from all across the world with their expertise. You see this now even happening in Taiwan. Taiwan is importing expertise from outside the world into Taiwan to support Taiwan Semiconductor and their expansions.
Mhm. Okay, so let us talk about the investment. You said that the kind of an investment that is required to grow your company is quite heavy. So, are you looking for external funding? And if yes, what are your criteria and how much fund are you looking at?
Yeah, so we have had some recent good progress on pitch events. So we've taken part in SEMI had a recent pitch for startup companies like us. So we made it to the semi-final in the sustainability pitch, and we got the chance to talk to the big VC companies based in Silicon Valley from the semiconductor industry. And this has generated a lot of bilateral meetings after that and attention. So by taking part in these pitch events and selling our approach, our technology, we have been able in web meetings like this to address the leading companies out there that are prepared to do this type of investments that we need. And we got last year, we closed this seed investment of $1 million, which brings us runway of the company financially to the end of this year, 2022. So we will need to take on more funds in early autumn 2022, and we are preparing for that now. And we have not set the level, but it will be in the, depending on what milestones we agree on, but it will be in the range of $3 to $6 million we want to take on this fall to extend and accelerate the development plan and go to 300 millimeter.
Any particular VC that you are targeting?
Yeah, yes. So two parts. We like to have the local support that we have already in the company. So it's very good to have a strong local support in Sweden, Scandinavia. So we will try to expand already the investors we have now and convince them to come in with more capital and to defend their ownership of the company. But we will have to raise a level. So we are looking at specifically VC capital from the semiconductor industry. And here there are three bags of sources out there. One is equipment companies, one is material supply chain like gas, chemical companies, but there's also the fabricators, so the integrated device manufacturers. They have their own VC branches, and we are talking to all three types. And we hopefully going ahead, we will be able to get together a consortium of different types of VC companies going forward and making this a real production technology.
Okay. So now, from the company's perspective, we will move a little bit towards knowing who Dr. Jonas Sundqvist is. So here, we would like to know about you as an individual in your personal life and professional life, and what keeps you going.
Yeah, so I'm born in outside Helsinki in Finland. I'm from the Swedish-speaking minority in Sweden. It's about 5% of the Finnish population speak Swedish as mother tongue. But earlier on, when I was only 2 years old, my family moved to Stockholm, Sweden. So I unfortunately don't know too much Finnish these days. It's a challenge for the future to learn my real mother tongue, so to say. So, but I'm grown up in South Sweden, countryside. I have a countryside growing up in the in the forest, in the fields, more nature type of person. So I enjoy camping, been grown up with the scout organizations, going on jamborees and camps, and I enjoy also today going out camping, tenting, and with the camper van driving across Europe. So what drives me is curiosity, and to reach achievements, to make an impact, to develop new methods, technologies that will actually go into high volume production. That's what's driving me. So for sure, I'm interested in the research part of this, but then I'm goal oriented. I want that what I work on will actually make a difference. And I think this opportunity with Helix Lab, one reason why I do this is that I see the potential to go into something that makes impact for the industry and eventually for all of us, getting more advanced devices that can be used hopefully in a peaceful way to enjoy life and get through tough situations like we all have now with the pandemic. But we are able socially to survive this lockdowns and everything because we can still communicate. And I think that communication globally has increased during the pandemic, whereas it has maybe locally been the biggest problem. How to keep connected to your friends that live close by, since you're not physically able to meet, but instead we have this opportunity to meet people that we would never have met before otherwise.
Mhm. Okay. So, how do you keep yourself abreast with the latest developments, whether it's on the technology aspect of the, you can say the business, or it's on the personal side?
Yeah, so I have since many years, I have a blog called Bold Engineering Blogs. It's about technology and specifically atomic layer deposition. So I've been running this for, I think it's 7 years now.
Mhm.
So I'm daily updating myself on that field and the related semiconductor field. I also work as a consultant for TechSet in California, which handle the Critical Material Council, and there I keep up to date with the fabs. So we are catering to the leading fabs and the ecosystem for critical materials, gases, precursors, and I also co-chair several conferences. Starting with the ALD conference in 2016 together with Simon Elliott, and then I moved on and done 1 or 2 conferences every year since then, locally in Germany, and also the Critical Material Conference, which takes place every year in the US. So this is how I keep up to date with what's happening.
Okay. Tell us about the company revenue and the kind of growth you are predicting in the next 5 years for the company.
Yeah. So at the moment, we don't produce any monetary value. We are burning investments basically. So, but going ahead, if we get licensable technology, the upside is enormous. Because it depends on what kind of revenue model you will have, but it's hard to speculate about how it will be. But in basically every time we take on we reach milestones, the evaluation of the company goes up, and it means that we can take on more investments. But eventually, everybody expects that we also have to. There's two: either we start making enormous amount of money, or we have an exit strategy and we would sell the whole technology or to an existing bigger company. So there's different exit models you can have in this field. You can also become on the a company, do IPO and go on the stock market. So there's basically 3 different models. We have not decided which one to follow. We are evaluating all 3 models at the moment. So it's hard to speculate on the long-term upside of this whole technology because it can be enormous. But the trick is to go there, right, and bring value each year. So we're really trying to enhance the value of the company, so the owners of this company see that we are creating value directly by getting a higher evaluation, which means if we have a higher evaluation, we can take on more investments and meet the next milestones. But eventually, the technology has to make money, because it doesn't make sense otherwise. And then you would get a return of invest in R&D, but it will be a considerable need for a continuous R&D budget. You can never stop with R&D in this field. So if you look at the big semiconductor equipment company, they have huge R&D spendings, and this they can't keep on running if they don't make money. So you have to have a revenue and a profit, a big profit of your technology. So, but in order to become, without making an exit, to build up a company that makes self-sustainable revenue that can fund the required R&D, this is a process that will take us at least 5 years.
Okay. So what kind of a future have you planned for yourself and your company in the coming years?
Yeah, so we want to build up strong R&D corporate headquarters in Sweden, in Lund. So we did the first steps now by reaching an agreement with Cleanroom and a Swedish research organization, ProNano. So we are equipping this Cleanroom now with our own equipment that we develop for our atomic layer edge pitch splitting technology. But on the same time, we need to engage the 300 millimeter infrastructure, and that's why we have an office also in Dresden, Germany, where I'm placed, to engage with the fab ecosystems here and get our process up and running in a pilot fab environment. So we work on this in parallel. So just for the next couple of years, this will be where we are placed. So Lund, Sweden, Dresden, Germany. Eventually, we will have to have also personnel in important markets like US, Korea, Taiwan.
Okay. So apart from whatever we discussed, Dr. Jonas, would you like to add anything?
Yeah, I would like to thank you for this opportunity. So to have this deeper going interviews that we had before with Electronics Club. I'm very happy for this, and we're also looking forward to reaching out to the broader community with this type of interviews and getting the chance to tell our story to the world. So we are very thank you for that.
Thank you, Dr. Jonas.